Okay, we're still in the reverse chain rule section. This one here, many teachers, including me, will already have covered this, so you don't even need to think of it as being reverse chain rule because you've been given a rule for integrating e to the kx, so you know exactly what happens. But you can do it with guess and differentiate, and you can do it with the linear function rule. Here's guess and differentiate. Okay, so it's e to the power of bracket. Well, I know that e to the x integrates to e to the x. I'm going to guess y equals e to the bracket, e to the 4x. But I know when I differentiate e to the 4x, okay, I get 4e to the 4x. You've learned a rule for differentiating e to the kx, or maybe you think that's chain rule, don't know. But we know it differentiates to that, so there's a 4 I didn't want, so my corrected guess, this was okay, but I didn't want the 4, so I need to put an antidote, a quarter, in front, so it's a quarter e to the 4x. Plus a constant. Okay, if you've learned the rule for integrating e to the kx, you just know it's 1 over k to the kx. If you do it by the linear function rule, then you integrate e to the bracket, you get e to the bracket, but then you look at the function, and when there's an ax, where there's an ax plus b as your linear function, then you get an extra 1 over a in front of your answer, and you can explain that's where the quarters come from. So this one here, this is not e to the kx, so we have to use one of the other rules. Okay, so I'll do linear function rule first time. Oh, and there's a 2 in front. Now this 2 I can forget all about till the very end. So if we think about e to the power of 5x plus 6, linear function rule says that this bracket here is a linear function, so I can just integrate. Okay, so I integrate e to the bracket, I get e to the bracket, e to the 5x plus 6. Okay, however, when I integrate a linear function, I have to put a 1 over a in front, and in this case my a is that 5, so I need a 1/5. So there's a 1/5 in front of that. Okay. And that would be the answer, but I've been ignoring that too, haven't I? So my point about the 2 is you just do ignore. I've done all of this. Oh, and then there was a 2 in front of that, so I can put 2 in front of my answer. I mustn't forget a plus c afterwards, and I should really tidy up. So this is equals 2/5 of e to the power of bracket 5x plus 6 plus c, double underline it. So that was linear function rule. Okay, guess and differentiate. You'd have guessed y equals e to the power of 5x plus 6. You'd have discovered that differentiates dy by dx would have been 5e to the 5x plus 6 using the chain rule. Okay, and then you'd have realized that 5, well, here you've got a choice. You can either think what converts that 5 that we don't want into the 2 we did want, or you could just think about removing the 5 to get this answer, okay, and then remember the 2 at the end. So do it in 2 stages, 2 simple stages, rather than thinking about what transforms the 5 into the 2, which would be 2/5. Does that make sense? Hope so. Okay, so we've got some more here along similar lines. So we're beginning to throw numbers in front of the functions, but you know the way to deal with that 3 there. Remember, a bit like differentiation, fraction with numbers times fraction with x's. This is 1 over 3 times 1 over e to the 2x. Okay, and of course you're not going to want to integrate 1 over e to the 2x. You're going to want to write that using a negative power. So the first thing to get started on here is to rewrite it as 1/3 times the integral of e to the power of minus 2x dx. Now you may be thinking, am I allowed to move that 1/3 outside the integral? Surely I'm supposed to be integrating everything. Why should that third get let off? Well, it's kind of like what we were saying with this 2 before. We know that when we differentiate or integrate double the function, we just get double the answer. Okay, so I can do all my integration and remember the 2 at the end, which is how we discussed that last one. So this is 1/3 of e to the power of minus 2x I'm integrating, but I can forget the 1/3 till the end. I can integrate the other bit and I can remember the 1/3 at the end. I quite like to do that because it means that I've got that 1/3 parked. I'm not really having to involve it in the integration. Now this to me is integrating the kx rule, but you can do it with the linear function rule. Here there are going to be limits on it, isn't that fun? But your first step here is going to be to split that into a fraction with numbers times a fraction with e's, so that you can put a fraction in front of the integral before you do it. So have a go at these. Okay, so this one, using the kx rule is what I'm going to do. So I have to have the k is minus 2, so I need the reciprocal of that. Gives me a minus 1/6. e to the minus kx. Sorry, to the kx. And I mustn't forget a plus c, so that's a straightforward one here. Okay, this one here. So if you've done the splitting up, it was a half times 1 over e to the bracket. So this is actually really half the integral from 0 to 0.25 of, and then it's a reciprocal of a power of e, so we need to think of this as being e to the power of minus 4x plus 1 dx. Okay, are you all right with that? Negative powers cause 1 overness, or basically we're saying that it is e to the power of the original bracket to the power of minus 1, because it was 1 over e to the power of the original bracket, and a power of a power, I multiply the powers. So the bracket times minus 1, that's where the minus 4x plus 1 has come from. Okay, so now I have got a linear function, so we could use guess and differentiate, or we could use the linear function rule. Okay, remember we are going to go into square brackets. That half can still stay outside, but it's a definite integral, so we're going to have 0 and 0.25. Okay, so you'll guess e to the bracket, you'd guess that it was e to the minus 4x plus 1. But if you were to differentiate that guess, you get a minus 4 popping out, which we don't want, so you'd need to have put a minus a quarter in front. And if you're using the linear function rule, that's again what you'd do, because you'd say this is ax plus b, and we have to divide by that a. Okay, so I hope that's all right. And then you've got to do the bit where you do the 2 sets of round brackets. Notice I've got this half in front of everything. I need an extra set of brackets. Okay, so I've got to do the bit where I put minus a quarter e to the, when I put minus 0.2, when I put 0.25 in, I'm running out of space. Minus 4 times 0.25 is minus 1 plus 1, so it's minus 1 plus 1. And when I put the 0 in, then it's still minus a quarter, but it's e to the power of 0 plus 1, because 4 times 0 is 0. So this is actually half times e to the power of 0 is 1. So it's half the power of minus a quarter times 1. And this is take away minus a quarter, so that's plus a quarter, and then this is e to the power of 1, so that's a quarter e. E to the power of 1 is e. So it is, there's a common factor here of an eighth, so this is 1/8 of e minus 1. Plus, not plus a constant, it's definite integral, we don't have constants of integration, it's just that answer. Notice we leave it in exact form. No one's interested in your decimal answer. If you remember, on any definite integral you can cheat. So any fool can do this, okay, and get a decimal answer, and of course there are no marks whatsoever for that decimal answer. But it is of some use to you, because of course it's an answer checker. So if I make my calculator do 1/8 of e minus 1, I should get the same answer. So here's e minus 1 divided by 8, and I get that answer, and the previous answer I got to the integral was that answer. Oh dear. Yeah, something's gone wrong, and what's gone wrong, of course, is I've just typed this in. So this answer checking, it can be really upsetting to discover you've done something wrong. Here, what went wrong was my check, which isn't very useful. I think I'm fixing it now. But if your check shows you've got the wrong answer, then is that useful information? Well, it might be, but if you can't find your error, it could just upset you. So this answer checker is kind of a bit double-edged, and really different people, I would advise different things about whether they use it or not. Anyhow, this is the thing that should match my 8th e minus 1, because I've changed that to a minus 1, and we get 0.2147, and when I did that, it now is the right answer. The nice thing is when your answer check confirms your answer. Alright, so those are some involving e's, and then the next section, which I'll do in another video, are these ones where we've got linear functions, very simple, linear function, very simple. We've got trig ones. So have a go, and I'll do these in the next video.